Hi, Chris Kuzmal here. We're looking at the rotate left helper number two. That is, there's three helpers to support rotation, whether that's a left rotation or a right rotation. And the second of the three helpers, in the case of rotating left, is called link ends parent to old nr. And so what we're going to do is we have n here. N has a parent, and whoever n's parent is going to instead become old nr's parent. And there's three possibilities. N's parent is the root. N's parent has it the case that n is the left child of that parent, or n is the right child of n's parent. And that's what this code explores. Those three goes through. It addresses those three possibilities. First of all, it's a public static void method, but I put that in very small font because it's not important to our discussion now. But I wanted, on the other hand, to have the full method definition on every slide. The name of the method is link ends parent to old nr. And node n as the argument to the method corresponds to n in our node n in our diagram. Node old nr corresponds to old nr in our diagram, as has been modified by our our first method. So we see old nr has been conceptually raised up so that its children now match what's supposed to happen at the end of the rotation. But also, there's a binary tree involved, and the binary tree provides the added information of what is the root of the binary tree. And that's the situation where n is in fact the root, but we need to be able to change, replace the root being n with the root being old nr, if that's the situation. So we have that at our disposal. And so the first thing we do is we find out what the parent of n is. And we set old nr's parent to be whatever n's parent was. But if that was null, then what we need to do is we need to set the root to be old nr. Okay, and so that means then that, and so that's what this setup is. We have old nr is now the root, and the parent of that root is by definition null. And n, which was the root, has a parent that's still null, but n is no longer equal to the root after we've done the operation of setting the root to be old nr. Now then, however, if n was not the root, there's two possibilities. One possibility is that, well, first of all, we're going to get the parent of n and check to see whether or not the left child of that parent is that n. If the left child of that parent is n, then we're going to set the left child of the parent of n to be old nr. Okay. On the other hand, it might not be the case that the left child of the parent of n is n, and in which case that means the right child of the parent of n is n, and therefore we're going to set the right child of n's parent to be old nr. So there were three possibilities, any one of which would have n's parent pointing somewhere, ultimately to old nr, whether it's pointing to its left child or its right child, or old nr is itself the root and there's not actually a parent. Those are the three possibilities that are accounted for in link n's parent to old nr. This does leave us with the uncompleted work of properly setting the pointer from n, because n's parent still is, n's parent now has a child which is not n, but which is old nr, and that's not the way it should be. N's parent looks like it's going to want to be old nr, but that will happen in the next and final helper method.